All right, so we're going to continue on with some examples that have variables, which in some cases are maybe a little bit easy. However, we're applying all the same kind of rules. So in this first example, we have a 3 outside the bracket. So we're going to simplify the individual brackets first. So this becomes 2 to the 3, x to the 9, y to the power of 3. Everything is impacted by that 3. Then in the second bracket, we're going to have 3 squared, x squared, and y to the negative 10. So now that we've removed that outside exponent, we are going to have 8, because it's 2 to the 3. I can't combine it with that, so I have 8. And I'm going to multiply it by 9 from the 3 squared. We're going to have x to the power of 11, and we're going to have y to the power of negative 7. So when I actually complete that answer, we have 72, x to the 11, y to the positive 7. So we had to move that negative 7 down to the denominator so that it's positive. That answer is now complete. For this example, before I do that multiplication step in, I'm going to change that exponent so that it becomes positive by moving down to the denominator. So I'm going to have 1 over, I have 27 to the power of 2 over 3, and I'm going to have y to the power of 9 times 2 is 18, divided by 3 is 6. So then I'm going to have 1 over the cube root of 27 squared y to the 6. So this becomes 1 over the cube root of 27 is 3, and then I square it, I get 9. So we have 9y to the 6. No negative exponents, simplified as much as possible. Okay, in this example, the 3 to the x has a negative exponent, and the x to the negative 3 has a negative exponent. So I'm going to essentially swap those. So I get x to the negative 3 over 2, 3x to the 2. This is one way of doing it. There are other ways of working out this question. So then I have x to the negative 3 over 2. 3 squared becomes 9, and then the x gets the 2 as well. So I have x to the negative 3 over 18x squared. So that's going to give me 1 over 18x to the power of 5. 5 is coming from the fact that if you subtract negative 3 and negative 2, you get negative 5. We don't want negative 5, we want positive 5. So you can just put it into the denominator, since that's the place where you have the most x's anyhow. Now, there are other ways of doing this. You could bring the exponents in to start off with. There are multiple ways of working it out. All right, I believe we're getting close to the end of these examples. So I'm going to have, that negative is like negative 1. So I have negative 1 to the power of 4, a to the 8, b to the 4. So that's the first bracket. Then I'm going to have that half is going to be impacting both values. So I'm going to have the square root of 16, since that's what 16 to the power of half is. I'm going to have a squared over b to the 1/2. So I brought that all in. Negative 1 to the power of 4 is going to go away. I'm going to have a to the 8, b to the 4, multiplied by 4a squared over b to the 1/2. So we get 4, a to the power of 10, b to the power of 4 minus 1/2. So that becomes 4, a to the 10, b to the power of 7 over 2. And I got that 7 over 2 by getting a common denominator with the 4 and change that to be 8 over 2. And then 8 take away 1 gives us 7, so that's where the 7 over 2 is coming from. In letter E, this is really x to the power of 12 over 3, which becomes x to the power of 4. So that's kind of going backwards. Often you have the exponent as a fraction and you have to turn it into a radical, whereas in this one, turning it back into an exponent as a fraction simplified it. So that concludes the simplifying exponent rules that you should remember from grade 11.